Hey everyone, welcome back to my channel EduVibe. Today we will doing the practice questions of the momentum and impulse of the second half. As we all know that we completed momentum and impulse. When we do the first half, we completed those practice questions in that video. If you want that video, so check the description of this video. And in today's we will do the second half and second half practice questions of momentum and impulse. In the next video we will do the diploma questions. So this video is more likely all the questions we have to discuss, some extra practice question we have to know in this. So our first practice question is from like two dimensions. So 4.0 kg object is moving east at the speed of 5.0 meter per second. When it collides with 6.1 kg stationary object, after the collision, 4.0 kg object is traveling at velocity of 2.8 meter per second, 32 degree north of east, and the 6.1 kg object is traveling at the same velocity, which is u vector. So there's lots of going on. We have a diagram for this. We have to know from the diagram. So we have like 4.0 kg object, and they're traveling with the 5.0 meter per second east. They mention over there they're traveling with the east. And then we have this velocity, this mass of 6.1 kg. This is at the velocity of 0. This is stationary, and when they both collide, this is the before collision. This all happened before the collision. After collision is like this. So when this object collide with this, they go with like this velocity, the u dash velocity they go with, and that v, that 4.0 kg go with the 2.8 meter per second velocity with 32 degree angle, which is of north of east. So this is the angle over there. So we have to find the that u dash, which is a u vector, and we have to find the velocity of this of 6.1. This is of 6.1 kg object. We find the velocity of this after the collision. So we have to find this thing. This thing we don't know. So how can we determine this? We have to know in this now. So they mentioned that we have a 2.8 meter per second 30 degree north of east. Let's see what we are making from there. So we have to make the vector diagram from here, and we start the question with this. So we have a vector which is the north of east. So this means that we have north, and this is our east, and this is our vector. So this is the right angle, and we have this angle of 32 degrees. And if we take that east, so east is the x-axis, so we take v1x and we take it final. Why final? Because we want to make the like final one. This after collision is the final velocity of this, so we take the final velocity every time in this question. So this is the north, and north is a y-axis, so it's v1f final. From here we know that this is 2.8 meter per second, we know. So from here, what we have to find? We have to find that v1x and v1yf. So for this, so we have v1yf first. So this is equal to 2.8, as you know that. And this is like, I will mention it, like we take north and the east as positive in this, because we have east as this positive and that north as also as positive we take. So the north and east is positive in that case. So 2.8 meter per second is the north, and we take positive, and we have to make like perpendicular we have to find, and we have that 2.8 hypotenuse, so it's sine 32 degrees. So make sure when you calculate this, you are in the degree mode for this type of question. We get 1.48377 meter per second when we calculate v1f. Then we have to find v1hf. This is again 2.8 meter per second. This is east, so we take it as positive. And this time we have to find the base, and we have the hypotenuse, so we take cos 32 degrees. So the v1hf is equal to what? When we calculate, make sure you're in degree mode. So we get 2.3745 meter per second. So from here we get the our v1hf and v1yf. So from here, when we calculate the x and y component, these two things used in this. So now we have to find the x and y components to find the velocity. So for x component I have, so this one is like something comes here and they hit and they rebonded. So it's a hit and rebonded. So we take P, this is S1 will be P1H, P2H will give you P1HF plus P2HF. We all know that at second object, which is 6.1 kg, stays at rest. This is at rest. So U is equal to 0. So we take this, eliminated this one. And rest of all we have, which is M1V1H is equal to M1V1HF plus M2V2HF. From here, what you have to find? We have to find this thing, V2HF. And from pure V2, because we have to final one. So we have to find V2. So that V2H final is equal to, so M1V1H minus M1V1H final divided by M2. So this thing is equal to what you have Y1, we have 4.0 kgs. For V1H we given that 5.0 meter per second minus again 4.0 kgs, and we have this, we find over there V1H. So it's 2.37 meter per second. This is the non-rounded value, and divided by 6.1 kgs. When we solve this, we get V2S final of about 1.72161 meter per second. So that's how you have to find the x component. For the same, we get the y component. So P1y plus P2y. So P1y final plus P2y final. From now here, that P1y, so our y is the north, and but that P1 is on the east. We know that this was in the east direction. So this will eliminate from here. This time that P2y again eliminate, because at initial this is at rest and we take 0 over there. So when we left with this bracket, and from here if it is M1V1F final plus M2V2Y final, we have to find this thing. So this will be isolated, which is V2Y final is equal to, so I erased this, and from here you get negative M1V1Y final divided by M2. So I put the values in. So V2Y final is equal to negative, M1 is 4.0, V1Y final we get from here, so it is 1.48 meter per second, and M2 is 6.1 kgs. So from here when we calculate that V2Fy, so we get about negative 0.972966 meter per second. So this is your V2YF and this is your V2S final. Now you have to find what? Now to find the resultant vector. From here you get the magnitude and the angle for there. So for the resultant vector, so now that V1H final is in positive, so this means those east as they have. So we have this is in east, that V2H final, but this time that V2Y, Y is in north, but this is now in negative. So this is negative, we have to take this at opposite direction, which is south. So this is going south, V2Y final. And we have to find this thing, which is U dash vector. So you know how to find, you have to take V2S final square plus V2Y final square, when you put the values in, that V2 as final is 1.721 sets 1 square plus negative 0.972966 square. That negative goes with the square and they put positive sign. So when you solve this, you get about 1.977530 meter per second. This is your vector, a magnitude. And for theta, you tan the theta tan minus, which is V2 final, Y final, V2 X final, and you put the values in, which is 0.9729 and we have 1.721 sets 1. And when you calculate this, make sure you're in a degree mode, so you get 29.472 degrees. So what's the direction is now? So this is your right angle, this is your theta you find. So what is the direction of this? So it's south of east. So it's south of east from here. Calculate all the things in, you get the magnitude of the final velocity of 6.1 kg object is 2.0 meter per second approximately and 29 degrees south of east. So that's how this question works. So you have lots of work going on. So this type of question is done to be around 6 marks, 5 to 6 marks in your examination or in diploma. So that's all what you have to show to get the 6 out of 6 in this. And make sure you can, like, if you have any doubt in this yet, so again watch this sum and clear your doubts. Next, we move on to the next question. Question says 2000 kg train car moving at 8.0 meter per second, right, collides with the 1500 kg train car at rest. After the collision, they stick together and go up a frictionless incline. Determine the maximum speed the cars achieved related to the ground. What's the going on? So here we have one cart, which is the 2000 kg cart, and this second, which is 1500 kg. This cart remains there as the rest. This car moving with a velocity of 8.0 meter per second, and when they collide with each other, they go and they stick together. In that case, they stick both together, that 1 and 2, and they goes over that red line 1. So we have to find that this height, that maximum height where they reach related to the ground. So for this, we have to find the height. So you all know that this is type of the word question. This is from the combining the conservation laws when we do the kinetic energy and the momentum conservation of energy, and we collide them all. So we can deal with this. So it is a hit and stick. So you have to find this. So from here, you know that P1 plus P2 will give you P1 to final. All know that P2 is at the rest. So it goes out. You only get M1 V1 is equal to M1 plus M2 and this combined mass final. This you have to find. So M1 V1, M1 plus M2. That M1 is 2000 kgs going to a velocity of 8.00 meter per second. Then we have 2000 plus 1500 kgs. Both are in kg. So from here, when you calculate, you get about 4.5714 meter per second. So that's your final velocity, combined velocity. Why we can find this? So we can find this because we know that EKA plus EPA is equal to EKB plus EPB. This we all know that. At the starting, that EK works, like goes with kinetic energy. First one is goes with kinetic energy, but potential difference is not there anything. The potential energy is not there, so it's left 0. PB is there because there's those with the height, which it goes with the gravity, but the kinetic energy of B1 is not there initially. From here we get what? That the EK is half mv square A, and that EPB is, you all know that, mghb. That mass should be the combined mass. That mass should be the mass 1 plus mass 2. But this mass goes out because they are in opposite direction. When they divide, they cuts out. So we only left with half VA square, which is GHB. We have to find the height, the maximum height. So HB goes over there. That half VA square divided by G. And when we calculate this, we get VA squared is our combined mass, which combined velocity, which we calculate this. So this we have to take over there, which is 4.5714 meter per second square. That 2 goes down, and this is 9.8 meter per second square. When you calculate, you get HB about 1.065 meters, which is also, we need 3 set this, so it's 1.07 meters. So this is your height, which is relative to the ground when both collide, when they both stick and they go the line. So that's how you have to find this question. It's an easy kind of thing. You get one question in exam or diploma too. So the last question of today's video. So here's all the things we have to given, like the 800 kg car traveling at 14.0 meter per second east collides with 1200 kg truck moving at 11.0 meter per second south. So you have to find the collision. They state together, draw a vector diagram for the collision and determine the total momentum of the system immediately before the collision. So to find the before the collision, what is this? So all the things before the collision, they stick together. Then, so we try to find a vector diagram. We have all the things given. They mentioned that this goes east. So this means the car's momentum goes east. And this 1200 kg to 11.0 meter per second, this goes south. So this goes south. That is for truck. And this is your total momentum you have to find. This is east, this is your south. Theta they didn't mention over there, we have just find the total one. So for the total momentum is P1 plus P2. I take this as 1, this as 2. We all know that this is equal to M1V1 plus M2V2. This simple kind of question is just to P is equal to 800 kgs, 14.0 meter per second speed they goes. Other one is 1200 kgs and this is 11.0 meter per second. From here, when we calculate the P, we get this 24400 kg dot meter per second. But if we in the standard form, if we want this, so shift with the points, you get 2.44 into 10 raised to power 4 kg dot meter per second. So that's your total momentum of this to find. So that's type of question you get in MCQ sometimes. So there's you find that first you have the vector in this. So this is an MCQ type question. In first MCQ you get the vectors and you have to find out which vector is most related to that question. After they mention that we have to find the total momentum. Sometimes they ask about find the angle to in the third MCQs. So the 3 MCQs goes with one question. So that's all for this lesson. We do the more practice question we deal with the now. We only restrict to only the half part of this unit of 2 dimensions. In the previous we restrict with the 1 dimension. But in the next video we'll combine them all. And we get that more and more diploma questions from here. That how can a type of diploma question be given? So the graph question we do in this, and we will going to do more and more complex questions, but this diploma style. So learning made simple with EduVibe, learn smarter but not harder. Please like, share and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till then, stay connected with EduVibe.